Welcome back. This is Chemistry question 52 from IMAT 2015 past paper. So I will be explaining how to solve this question. So let's move on forward. It says which one of the following 0.01 molarity, which is concentration of aqueous solutions, has a pH greater than 7. So we have 5 given list of these compounds. So one of them we must determine if which of these, if dissolved in water, form the resultant solution that is going to be basic solution, as it says pH more than 7. So pH more than 7 is basic solution. So it must form a basic solution. So we must go through each 5 list of these compound to determine which is going to form this basic solution. But first we must identify what type of compounds are these, whether they're ionic or they're salt or they're acid or base. So we have to identify that first. So we are given with aluminium bromide, sodium iodide, ammonium chloride, and sodium carbonate, and we're given with carboxylic acid. So we must know that only option E is an acid itself, but rest of these given option, rest of these compounds are actually salts. So we know we can easily first cancel this option out because we know we're asked to find which forms a basic solution. Okay, so pH more than 7. We know this is an acid itself, so it will dissolve in water and protonate. So it will form acidic solution, not basic solution. So we'll easily cross this out as an incorrect option. And now we're going to focus 4 of these options. So we know now we have confirmed it that these 4 options are actually salt. So now before we jump into the answering this question, we must first recall the main key points to make it easier to solve this question. So the main key point is that first of all, we must know that there are some ions, that there are some salts when they dissolve in water. Okay, so I'm going to write here the main key point. Some salts that dissolve into ions in solution in solution its ions will hydrolyze with water, resulting in solution with change in pH. Okay, so there are some salts that dissolve in ions, so we know that some ions will hydrolyze with water, meaning they react and they result in specific solutions, specific pH in the solution. So there's going to be change in pH, but we must know that why there is change in pH. Okay, so what causes the change in pH? So there's a second most important rule we must know, that ions of salts, ions of salts that are derived from weaker parent species, which is most commonly acid or base. Acid or base generally undergoes hydrolysis with water, and so this with water resulting change in pH of a solution. Okay, so using this law, we must determine the specific parent acid or base for these salts, because we generally know that acid reacting with base generally form salts, and plus water. So water and byproducts depends on what type of compound is the acid, whether they're carbonate, whether they're hydrogen, like hydrogen chloride, and also for sodium hydroxide, the base and alkali. So we must, it depends on the composition of those acids and base that will determine the salts, whether it's going to be acidic salt or the basic salt. So now we can go through each of these options, but before that, there are actually two methods of solving this question. So is the first method is determining parent acid and base of salt. So the second method is constructing ionic hydrolysis chemical equation. Okay, so there are two methods for solving this question. The first method is we determine the parent acid and base, the species of a salt. So we must know the origin of the salt, like from which type of acid or base the salt was originated from. And the second method is that we construct the ionic hydrolysis, the chemical equation for ionic hydrolysis. So the ions of the salt reacts with water and forming the products, and by its product we're going to determine and predict the pH of the resulting solution. Okay, so now let's first use the first method. So the first method, that is the, in short form, the origin of salt, the origin of a salt. Okay, so now we'll go for the first option, which is option A, aluminium bromide. Okay, so for this one, we know that aluminium, we can divide this into two. So first of all, aluminium is a metal and bromide is a gas. So we basically know that most commonly the metal form more basic solution, and the gas, the non-metal, basically form an acidic. They generally form acidic compound. So we can divide this into two. So they're most likely the parent acid or base will be the hydrogen bromide plus plus aluminium hydroxide, which gives the product aluminium bromide and plus water. Okay, so now we have to determine which is the weak acid or which is the weak acid, strong acid, or the weak base or strong base. So we have to predict the strength of these species, the acid and base. So okay, so we generally know that hydrogen halides are basically strong acid. So bromide is, the bromine molecule is actually belong to halogen group. So we know hydrogen halides are basically strong acid. So they are generally strong acid. So we can mark this down, strong acid. So I'm writing the short form A for an acid, and aluminum hydroxide is actually weak base. So basically, we know that aluminum hydroxide are actually amphoteric hydroxides. So that's why we consider this as weak base. So therefore, its salts, when they form a solution, it most likely form a pH less than 7. So it's going to be acidic solution. So option A is cancelled out. So now let's go to option B. So option B, we have sodium iodide. So as we did for the option A, we divide this into two. So most commonly, metals form basic compound and non-metal form an acidic compound. So we have iodide and sodium. Okay, so we can predict the most common acid and base. The parent acid and base will be hydrogen iodide, hydrogen iodide plus sodium hydroxide, and this will produce sodium iodide plus water. Okay, we know, as we discussed for the hydrogen bromide, we know the halide hydrogen halides are basically strong acids, so we'll mark this down as strong acids. And for sodium hydroxide, we know this is going to be a strong base. So therefore, its resulting salt that will form a solution will have pH equal to 7, which is going to be neutral. So it will form a neutral solution because this is neutral salt. So if it is dissolved in water, it won't hydrolyze with water and form any new product. So it will stay neutral and it won't react with water, which is hydrolysis. Okay, so we can also cancel this out. Option B is also incorrect. Now moving to option C, which is aluminium chloride. Oh, sorry, it is ammonium chloride. Sorry. Okay, so option C. So now, as we discussed the rule behind these option A and B, where we divide metals and non-metals, here it's going to be slightly changed because even though nitrogen is non-metal, but still it is going to be basic actually. So it's not going to be an acidic. But chloride here will have its origin, its a parent species going to be an acid, which is hydrogen chloride, and the ammonium is going to be its parent base is going to be ammonia. Okay, so now I'm going to write the equation down. So it's most likely uh, parent species acid and base is going to be hydrogen chloride plus we have ammonia NH3 that will give NH4CO, ammonium chloride. Okay, so as we discussed for hydrogen halides, it's going to be strong acid. Okay, and ammonia is generally weak base. Okay, so we know its resultant solution with this salt is going to be acidic. pH is going to be less than 7, so it's going to be acidic. And now we'll move to the fourth option, which is option D. So we can cancel this out. So now option D. Okay, so now option D is sodium carbonate. So now we have to predict its parent acid and species. So the most likely parent acid and species will be sodium, wait, hydrogen carbonate sorry, it's carbonic acid plus sodium hydroxide, sodium hydroxide, and this will produce sodium carbonate plus water. So now we can predict that this is weak acid, carbonic acids are weak acids, and sodium hydroxide are strong base. Okay, so the most likely the pH or resultant solution formed by this salt will be basic solution, pH more than 7. So this is going to be basic. So now we can correct this. So the correct option is option D, sodium carbonate. So this is the only correct option. Sodium carbonate will result in the solution, basic solution, pH more than 7. Okay, so that's how we solve this question. And so this was the first method. Now I'm going to explain the second method, which is constructing ionic hydrolysis, the chemical equation for it. Okay, so now moving to the second method. So the second method that I'm going to be explaining is ionic hydrolysis equation, the chemical equation. Okay, so for the first option, the aluminium bromide. Okay, so the aluminium bromide is going to dissolve in water and form aluminium ion 3 plus and 3 bromide molecules. So all of these are in aqueous solution. So this is dissolved. Okay, so these ions, the salts are actually dissolved into ions. So here, aluminium ion, the cation, is going to act as Lewis acid, but whereas the bromide is just going to stay as a spectator ion because it's highly stable ion, so it's not going to react or nor hydrolyze or get hydrolyzed. So it will just stay as bromide ion as its spectator ion and it's highly stable neutral ion. Okay, so now I'm going to construct the equation aluminium ion reacting with a water molecule. So this will result in aluminium hydroxide with 2 plus charge because hydroxide is of -1 plus the proton. So that's why this forms a solution acidic. So pH is less than 7, which is why it's acidic. So now this is option A. For option B, okay, for option B, it is sodium iodide. Okay, so sodium iodide will dissolve in water to form sodium ion plus iodide ion. So this is dissolved. Okay, now we know both sodium, as we discussed before, that sodium iodide base forms neutral solution, so there's no change in pH. So why is that? Because sodium ion and iodide ion are stable octets because it has its octet, the outer shell of electron completed. That's why it results in stable ions. And this rule, stable octet, also applies to bromide ion, which is why it's considered a spectator ion. So similarly, sodium ions and iodide ions are also spectator ions. So there's no hydrolysis reaction. So no hydrolysis. Okay, so both of them are spectator ion just as the bromide ion, so thus it does not undergo hydrolysis. Okay, so now option C, which is ammonium chloride and H₄CO₃. Okay, so this will dissolve in water to form ammonium ion plus fluoride ion. This is dissolved. Okay, so we must know that ammonium ion acts as Bronsted Lowry acid and fluoride ion, just as bromide ion, iodide, and sodium ion. Chloride ion is also spectator ion. Okay, so now we're going to focus on ammonium ion. So the ammonium ion undergoes hydrolysis. So ammonium ion plus water forms ammonia and hydronium ion. So we know this hydronium ion is an acid. So thus the pH will be less than 7, which is acidic solution. Okay, so now moving on to option D. So hydronium ion basically also dissociates into water and proton, and that's why the resultant solution will be acidic. Okay, so this is acid. So that you must know. Okay, so now for option D, we had sodium carbonate, which is Na2CO3 sodium carbonate. So this will dissolve into sodium ions, two sodium ions, and one carbonate ion. So dissolved equation. Okay, so we must know that the carbonate over here acts as Bronsted Lowry base, as it's going to accept the proton from the acid, and the sodium ion is going to stay a spectator ion. Spectator ion. Okay, so now the chemical equation, carbonate reacting with water, the hydrolysis reaction. So this will form hydrogen carbonate plus OH minus. So we know it produces hydroxide ion when the carbonate undergoes hydrolysis. So therefore the pH, the resultant solution is going to be basic. Okay, so it's going to be basic. So now option E, which is the carboxylic acid that we've ruled out easily, but I'm still going to write down the formula since it's second method. So for clarity, so carboxylic acid uh, reacting with water. So this forms carboxylate ion and hydronium ion, which is generally an acid that will dissociate into water and proton. So this will result in pH to be acidic. So that's all. This is how we solve using a second method, which is constructing chemical equation for an ionic hydrolysis for each of these salts, and also this acid that undergoes hydrolysis, resulting in pH to be acidic. So these are the two methods to solve this question, to determine the pH of the resultant solution to predict the pH. So that's how we solve this question. Okay, so that's the end. So thank you guys for watching my video. I hope you find it helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.